Again, we're going to solve the same problem, but we're going to solve this problem looking at it a little bit differently. We have these regions right here. Again, we took, looking at area in terms of summations, we were summing up these infinite rectangles and we were getting the heights, an infinite number of heights in here to come up with our solution. But what we're going to do now is we're going to look at this list a little bit differently, because we had to do this at two different values. But let's look at if we rotated this problem 90 degrees. Now all of a sudden, to describe the area inside of this region, we could describe every aspect of the area inside of this region as just being the going from here to here, here to here, here to here, here to here, and so forth. So now I could actually show these in one region. The only problem is that now I'm looking at it within a y value. So I have to rewrite my equations, solving them for x. So instead of saying f of x equals x to the 2/3, I'm going to say this first one is y equals x to the 2/3. So y to the 3/2 is going to equal to x. And instead of this one being y equals x minus 4, it's now x equals to y plus 4. So I need to know the area going instead of top to bottom, which is what I did earlier. I want to go from right to left. So my right equation is this y plus 4 equation. My left equation is this x to the 2/3 equation. So my integral, and I'm going to be able to write it in one integral, it's from 0 to something. Again, we need to figure out what this value is going to be. But it's going to be from 0 to something here of y plus 4 minus y to the 3/2. Now, where do we find what the y value of this intersection point is? Because remember, this 0 right here is the y value. So we need to figure out what this y value is, and of course this integral is going to be a dy integral. So we need to get these equal to each other. So let's set x to the, let's set y to the 3/2 equal to y plus 4. And from here, all right, let's square both sides. So we get y cubed equals y squared plus 8x plus 16. So this becomes 0 equals y cubed. I'm going to pull everything from this side over here to make it negative. So it's minus y squared minus 8x minus 16. Now, from the intersection standpoint, let's just try something with synthetic division. Let's try 4 here. All right, so we've got 1, -1, -8, and -16. So 4 and 1 is 4. 4 minus 1 is 3. 4 and 3 is 12. 12 minus 8 is 4. 4 times 4 is 16, so we get 0 here. So this intersection point is when y is equal to 4. So let's think about what that means for us. Now we've got the integral in terms of our y values, and we're going, instead of from 0 across here, we're going from 0 up to 4. And again, everything in this region can be described as the line y plus 4, take away the curve y equals, x equals 3, I'll get it right in just a second, x equals y to the 3/2 power. All right, so let's do the integral here. And you're going to see that this is going to work out a lot nicer than this did right here. So this is going to be y squared over 2 plus 4y plus, this would be 2 fifths y to the 5/2 from 0 to 4. Again, all we have to do is plug in 4, because if we plug in 0, we'll get 0 here. So 4 squared is 16. 16 over 2 is 8. 4 and 4 is 16. And then the square root of 4 is 2. 2 cubed is 2 to the 5th is 32. 32 times 2 is 64. So it's going to be minus 64 fifths. So we have 8 and 16 is 24. Minus 64 fifths. So this would be 120 minus 64 over 5 with the common denominator here. So what do we get? We get 56 fifths. The same exact thing we did here. So to sum it up, and I'll have your homework problems from the worksheet packet on area posted in the comment section here. But what we're looking at here is we're looking at two different ways to describe the same region. The main thing is that you first need to figure out where your region is, what your top equation is or what your bottom equation is. Or if you want to do it in terms of y, what your right-hand equation is and what your left-hand equation is. And you also need to know from that the intersection points. To find your intersection points, unless you're specifically asked to go from one A value to another B value, to find those intersection points, you set the equations equal to each other. So hope you enjoy your ice day. If it doesn't ice, then you watch this video. You'll get to hear me teach it again Monday and Tuesday in class. Thank you. Bye.